Bennu, this half-kilometer-wide, carbon-rich behemoth, isn't just on the Sentry list. For years, it has held the #1 slot as the most hazardous asteroid currently known. Its potential impact energy is estimated to be over 1 billion tons of TNT, enough to cause regional devastation, trigger massive earthquakes, and unleash a climate-altering dust cloud that could plunge the Earth into a brutal multi-year winter. But the controversy surrounding Bennu is not about if it could hit, but why its orbit is so maddeningly hard to predict. The culprit is a tiny, invisible force, the Yarkovsky effect. Imagine the sunlight hitting one side of the asteroid, warming it up. As Bennu spins, that warmth is later re-radiated away as heat. That heat acts like a minuscule natural rocket thruster. It's an almost immeasurable pressure, the equivalent of the weight of a few grapes constantly pushing on the entire rock. But over centuries, this constant shove is enough to subtly yet fundamentally change its trajectory. This is why NASA launched the $1 billion OSIRIS-REx mission to literally touch the asteroid, measure its precise composition, and sample its surface to calculate exactly how the sun's push affects it. The clock is ticking toward a critical date, September 24, 2182. Bennu has a 1 in 2,700 chance of striking Earth on that day. However, the more immediate danger is in 2185. That year, Bennu will pass through a series of gravitational keyholes, areas of space so specific that if the asteroid passes through just one of them, the Earth's gravity will deliver a perfectly timed catastrophic slingshot. This gravitational nudge would precisely line Bennu up for the 2182 impact. The OSIRIS-REx data is our only hope for mitigating this future crisis. Without that sample, without knowing the asteroid's precise density and thermal properties, the 1185 keyhole passage would be a pure game of cosmic roulette. The fact is, humanity spent $1 billion not to visit Bennu, but to defend against it. 1950 DA. This behemoth measures a terrifying 1.3 kilometers across, easily classifying it as a civilization ender. Its mass and velocity are so immense that an impact would unleash energy equivalent to over 75 billion tons of TNT, a force capable of ejecting enough material into the atmosphere to block out the sun, collapse global climate systems, and cause widespread, unavoidable crop failure. This is the kind of rock that causes a mass extinction. Discovered in 1950 and then lost for half a century, its rediscovery led to a chilling pronouncement. The initial calculations gave 1950 DA the highest impact probability ever known, setting the stage for a potential strike on March 16, 2880. While subsequent, more advanced observations have significantly lowered those odds to a still terrifying 1 in 34,500, the threat remains critically active. The reason for the enduring uncertainty is a complicated mix of factors, once again centered on the Yarkovsky effect. 1950 DA is believed to be a rubble-pile, a loose collection of rocks and dust held together only by weak gravity. Compounding this, it has a retrograde rotation, meaning it spins backward relative to its orbit. This bizarre combination makes the solar-induced trajectory shift almost impossible to model, with 100% accuracy over the 800 years until its close encounter. Think of it as a massive, loosely bound cannonball spinning the wrong way. The internal chaos of its structure combined with external forces means that no one can definitively say we are safe. Because of its sheer terrifying size, 1950 DA has earned its permanent place as one of the 2 most critical objects on the entire Sentry risk list, a global threat looming far out in the cosmic future. The God of Chaos, 99942 Apophis. When the 340-meter-wide asteroid was named Apophis after the Egyptian god of evil and destruction, it was a direct reflection of the fear it inspired. When discovered in 2004, it carried a stunningly high calculated probability of impact in 2029. For the first time, a celestial object was ranked level 4 on the Torino scale, the first and only time an asteroid has reached that level of immediate concern. The world panicked. Deflection strategies ranging from simple paint to nuclear options were openly debated. The greatest drama, however, played out over the next 17 years. Astronomers worked relentlessly, refining its orbit. Finally, after a massive radar campaign in 2021, they were able to rule out an impact for at least the next 100 years. Humanity breathed a collective sigh of relief, but the story is far from over. In April 2029, Apophis will make its closest approach in recorded history. It will pass Earth at a distance of only 32,000 kilometers, closer than many of our geosynchronous satellites. This isn't just a flyby, it's an astronomical trauma. The Earth's immense gravitational field will subject the asteroid to tidal forces, pulling and stretching it, potentially causing seismic activity on its surface, changing its rotation, and fundamentally altering its orbital characteristics. This is a terrifying natural experiment being conducted right on our doorstep. To capitalize on this unique event, NASA repurposed the OIRIS-REx spacecraft, now known as OIRIS-APEX, to rendezvous with Apophis shortly after the 2029 encounter. The mission is to study the fresh wound, to see how the asteroid's surface, composition, and rotation were instantly changed by Earth's gravity. The stakes are immense. Apophis is no longer a threat, but it is the ultimate test case. Its close call is giving scientists an unprecedented chance to study the effects of a planetary gravitational field on a potentially hazardous object, providing crucial data needed to save us from the Bennu and the 1950 DAs of the future. The Blue Spectre, 3200 Paethon. This 5.8-kilometer colossus is an enigma, a massive asteroid that behaves like a comet. It is officially classified as a potentially hazardous asteroid, and its sheer size makes it a true planet killer, an object large enough to cause global devastation and mass extinction far beyond human civilization collapse. Paethon's orbit is the most extreme of any numbered asteroid. It swings closer to the Sun than any other named object, almost skimming the solar atmosphere. At its closest, it faces temperatures over 1300 degrees Fahrenheit, causing its surface to literally bake and sublimate. This intense heat causes it to eject a stream of dusty debris, which is why Paethon is known as the parent body of the beautiful annual Geminid meteor shower. Every December, when you watch a shooting star, you are witnessing a tiny, harmless piece of this colossal threat impacting Earth's atmosphere. The danger is twofold. First, its close proximity to the Sun causes the Yarkovsky effect to be extraordinarily strong, making its long-term trajectory highly complex. Second, its orbit is so eccentric that it cuts violently across the orbital paths of 4 planets, Mercury, Venus, Mars, and Earth. While no immediate high-probability impact has been calculated, its massive size combined with its unpredictable, scorching hot orbit ensures it remains on the Sentry list. The 2024 close approach, though distant, was closely monitored. The underlying truth is that an object this large, with an orbit this chaotic, is a ticking time bomb, one that we are forced to study from afar as it generates its annual light show of beautiful, deadly debris. 2023 DW. This 50-meter-wide asteroid, roughly the size of a football field, was briefly ranked a 1 on the Torino scale, the only object to achieve that status at the time. The reason was a specific, terrifying prediction. Its potential strike date was February 14, 2046. The public quickly dubbed it the Valentine's Day asteroid. This rock's immediate notoriety stemmed from its size. At 50 meters, it is chillingly comparable to the object that caused the 1908 Tunguska event. That blast, which occurred miles above the Earth's surface, flattened an immense, 2,000 square kilometer stretch of Siberian forest. It was the largest celestial impact in modern history, and the terrifying prospect was what that blast would do over a densely populated area. A hit near a major global city would have resulted in millions of deaths and unprecedented regional destruction. The brief threat of 2023 DW was a perfect high-speed demonstration of planetary defense in action. The moment its initial alarming trajectory was calculated, telescopes around the world immediately pivoted. Within weeks, the torrent of new observational data allowed astronomers to precisely model its path. The impact scenario was quickly eliminated, and the asteroid was officially removed from the risk list. The 2023 DW incident became a testament to both the constant, hidden danger posed by smaller, newly discovered near-Earth objects, and the remarkable effectiveness of the global monitoring system, a success story that quickly faded from the headlines, even as the threat it represented was real. 1979 XB. While asteroids like Bennu and Apophis command headlines, the most insidious danger often hides in plain sight, the large, older discoveries whose paths are not precisely known. Enter 1979 XB. It is classified as a potentially hazardous asteroid due to its size, likely well over 140 meters, and its orbital proximity to Earth. It has the mass to unleash catastrophic regional devastation, yet it remains one of the greatest blind spots in planetary defense. The core issue is a lack of data. Discovered decades ago, the asteroid's initial observation arc was very short. This older, sparser dataset means that even after subsequent tracking, its calculated trajectory has a large margin of error. It is currently not one of the top-ranked threats, but this isn't due to certain safety, it's due to high uncertainty. Its path is not precisely pinned down, meaning that over the coming decades, gravitational perturbations could easily shift its trajectory into a hazardous zone without us having sufficient lead time. 1979 XB quietly represents the massive dark underbelly of the Sentry list, the large objects that are simply too poorly tracked to guarantee safety. Scientists are forced to play a continuous tense game of catch-up, constantly seeking better observations to eliminate the terrifying possibility of an unforeseen high-speed collision. The fact that a potentially catastrophic object exists in this state of high uncertainty is a constant reminder that for every Apophis that makes the news, there are dozens of other sleeping giants whose orbits remain a chilling open question that could be resolved in the worst possible way.